Concerning the finite automata, we have to know what is language, how to draw the transition table, and what is transition function and usage of transition function, and whether the string is accepted or rejected. Okay, so this is a given problem. You have three colored bars like red, green and blue. The goal is to place these balls on a table one by one in a specific order. So anyway, we are having the possibilities 3 factorial, and we are having 3 colored ball like red, green, blue. So these are all the possibilities definitely. Here, based upon these problems, we are giving the finite automata, and also we have to ensure we can get all the possibilities for this figure. Here, the finite automata consists of 5 tuple, that is Q. Q means number of state like Q0, Q1, Q2, Q3, and alphabet. Alphabet in the sense that is an input. Here, what is the input for this given problems? That is a red, green and blue ball. And transitions. Transition means it can move from one state to another state. And Q0, it is a initial state, and F means it is a final state. Final state, we can say accepting state as well as reachable state. Okay. Then what is language? So sequence of possibilities we can generate, that is called language. So given problem we can generate these possibilities. We can say this is a string, it's a combination, and a sequence of string is called language. Here we can represent the L in mathematical notations. So this is a string. And so this is a transition functions. We can represent the delta. We just how to write means here the transition of that is called a delta of Q0 comma R. It will reachable to Q1. That is the output. So like that we have to represent the transition diagram. And also one more thing, transition table. Transition table here, that is called input. This is column we can represent as a number of state. Here this arrow mark represents a initial state and star represents as a final state. Here you see the same transition functions, again we are representing through the transition table. Here Q0 to R means Q1, Q0 to G means against Q1, then Q1. So like that, Q1 to R, Q1 to G, Q1 to B, we are getting the Q2, then Q2 to R, Q2 to G, Q2 to B, we are getting the Q3, then Q3, there is no any value, we can represent as a null. So this is way of representing the transition function, transition table, and way of interpretation of the automation. While making the finite automation, we have to start with starting state, and we have to think all possibilities. Suppose we are using R comma G, here we couldn't get the blue ball. Okay. Suppose R alone, suppose we are using R alone, we are getting only red ball only. But whatever, what is actually given problem, it must be 3 colors, 3 ball. So that's why we have to draw like this. If you are giving any one input, definitely you are placing only one ball here. So that's why we have to give at most all the possibilities for the transitions. For example, we will move from, suppose you are going to arrange red, green, blue. So it will support. First, it will start for a red, and it goes to the Q1 transition, and it will start again, it will goes to by the input green, and next it will goes by the input maybe blue. So at a time, suppose you are giving the 3 input, but at a time it will take only 1 input. All processing machines, that is a concern the finite automata, at a time it will process only 1 input. So like that we have to draw the machine. So always ensure that what is initial state, what is final state, and what is the possibilities of input. Then we can represent like this based upon this question. And also finally, we have to ensure whether the string is accepted or not. So through the transition function, we can check whether the string is accepted or not. So this is a valid string because the given constraint is specific ordered. So we are having a 3 balls. Here also 3 balls, here also 3 balls, 3 colored ball. Not green, green, red, not blue, blue, red. So this is not given question. Suppose they are asking you how to arrange blue, blue, green or red, red, green. Again you have to redraw the transition, redraw the finite automata. So now we can ensure whether the string is accepted or not. You see here transition of Q0 comma, you are taking any string here. So suppose I am taking RGB. First you have to check Q0 with R in the transition table. Q0 with R means you are getting the answer Q1. Then remaining value. Again you have to ensure what is the transition for Q1 and green. Q1 and green you are getting this Q2. Then again you have to ensure Q2 comma B means, so you are getting this Q3. Now you say then the string is also empty and we are reaching this final state Q3. Hence we can announce the string is accepted. Here not like this. So definitely this condition not satisfied. Suppose you are taking RG, that is a 2 input. Our goal is need to arrange 3 ball, that is 3 different color balls. Okay. So RG. So now you check Q1, Q0 comma R means what? Q1. Again Q1 comma G you are getting Q2. So Q2 is not a final state. When the string is accepted, you are reaching starting state to final state. We can announce the string is accepted. Now you see R not possible, but we are getting the string is red, green, blue. So any combination you can take it. So like that we have to draw the machine. Thank you.